Hello everyone, myself Monish. My question is 1DA18EC081. What is LVDT? Linear Variable Differential Transformer is an inductive transducer which converts linear motion or displacement into electrical signals. LVDT works on the principle of mutual inductance.
Hi, myself Manjunatha Gowda Hen, USN 1DA18EC078, going to explain about construction and principle of LVDT. A linear variable differential transformer is an electromechanical position transducer which provides accurate and frictionless positional feedback information about the linear mechanical position of an external force or an object. Principle of working of LVDT. When two or more long solenoidal coils are wound together onto the same former or core, the magnetic flux produced by any one of the coils links to the others with the magnetic flux produced by the driving coil or opposing the flux produced by the other coils. Thus, any AC current flowing through one coil will induce a voltage into the other magnetically coupled coils, and this is the basic principle of LVDT. Construction. The Lvdt consists of three individual coils wound sequentially around a hollow non-magnetic insulated tube. One coil of magnetic wire is classed as the primary coil and the other coil form two identical secondaries. The secondary coils are connected together in a series opposing configuration, that is, they are electrically 180 out of phase with each other, hence the differential part is its name. The Lvdt single centrally located primary coil is energized by a constant AC sinusoidal waveform source with a frequency ranging between about 1 kHz to 10 kHz. The magnetic flux produced by the primary winding is coupled through the core to one or both of the two secondary coils placed either side of it. This arrangement produces a differential output voltage proportional to the core's displacement, thus giving it the additional name of displacement sensor. Then the Lvdt consists of one primary excitation coil and the two secondary coils connected in series opposing. A soft iron ferromagnetic core called a core, slug, plunger or armature is allowed to move freely inside the central hollow tube in a straight line as a result of the displacement of the connected object increasing or decreasing the mutual inductance between the primary and the secondary coils, which in turn increases or decreasing the voltage induced in each secondary coil, producing a very accurate device for measuring linear displacement and whose output is proportional to the position of its movable core, hence the linear variable part of its name.
Hi, myself Rakshit Gowda K. I am here to explain the working principle of LVDT. The working principle of linear variable differential transformer or LVDT is based on mutual induction. The primary winding of LVDT is supplied with AC supply, due to which it produces alternating magnetic flux in the core, which in turn link with the secondary winding S1 and S2 to produce EMF due to the transformer action. Now, let us see how LVDT works in three different cases. Case 1. Core at null position. When the core is at null position, the flux linking with both secondary windings is equal, hence equal EMF are induced in them. Let the output voltage of secondary winding S1 be ES1 and of secondary winding S2 be ES2. Therefore, the differential output voltage is given by E0 is equals to ES1 minus ES2, which is equals to 0. Case 2. Core is moved to the left of the null position. When the core is moved to the left of the null position, more flux links with the secondary winding S1 and less with the secondary winding S2. Hence, the output voltage ES1 of secondary winding S1 is greater than the ES2. Therefore, the differential output voltage is given by E0 is equals to ES1 minus ES2, which is a positive value. And the output voltage E0 is in phase with ES1. Case 3. Core is moved to right of the null position. When the core is moved to right of the null position, more flux links with the secondary winding S2 and less with the secondary winding S1. Hence, the output voltage ES2 of the secondary winding S2 is greater than ES1. Therefore, the differential output voltage is given by E0 is equals to ES1 minus ES2, which is a negative value. And the output voltage E0 is in phase with ES2. From these three cases, it's clear that the amount of voltage change in either secondary winding is proportional to the amount of movement of the core. The output voltage of an LVDT is a linear function of a core displacement within a limited range of motion. Above this limited range, the output voltage is nonlinear with core displacement. And at null position, that is when there is no displacement, there is some output voltage called residual voltage, which is due to residual magnetism in the iron.
Hello everyone, Pratik here, US and 1D18EC099. I'll be starting off this by telling about advantages of Lvdt. It has high measurement range, it has low power consumption, it is frictionless device, it offers high resolution which is greater than 10 millimeters, it has highest sensitivity of greater than 40 volts per millimeters, it is smaller in size, it is less in weight, it has lower hysteresis, it is solid and robust in construction, hence it is tolerant to shocks and vibrations. It has excellent repeatability, it has very low output impedance. Next slide is about disadvantages of Lvdt. Large displacement is needed for small output. It is affected due to external magnetic field and hence the entire Lvdt circuit needed to be shielded to achieve desired accuracy. The performance of Lvdt is affected due to increase in temperature. So the change in temperature causes the change in performance. Vibrations due to displacement can affect the performance of Lvdt device. Thank you.
Hey guys, this is Rakesh G here and my USN is 1DA18EC105. So the topic I'm going to explain is application of linear variable differential transformers. So before going to the application part, let us understand what Lvdt means. So Lvdt is an electromechanical sensor that converts the rectilinear motion of an object to which it is mechanically coupled into a corresponding electrical signal. So this is what Lvdt means. Now let us see the application part. Going to the next slide. So Lvdt application types. There are two main ways in which an Lvdt can be used: main transducers and secondary transducers. Going to the next slide. So coming to the application part. So application in the energy and aerospace industries. So basically in energy sectors we need highly accurate sensor technology. Force sensors, displacement transducers and temperature measurement sensors are commonly used tools. So in aerospace industries, the constant evolution of jet engine manufacturing requires the use of variety of contact and non-contact precision aerospace sensors. So this is applications in energy and aerospace industries. Now let us see the application in electronics industries. Lvdt sensors are used by manufacturers across the industry spectrum from aerospace, automotive and construction to electronics, energy and environmental, and are critical to the development of products of all sizes. Now let us go to the next slide. So Lvdt rig is better for tensile test measurements shown in the figure, and linear displacement transducer to measure pressure and load. Going to the next slide. Now let us see the other applications. As I said, Lvdt has vast applications in the world. Let us see the applications in power turbines. So power turbines in power generation turbine application for power plants around the world use linear variable differential transducers as position sensors with a signal conditioner to provide the necessary operating powers. And application in hydraulics is linear position sensors serve as charge sensors in hydraulic accumulators. And Lvdt has applications in automation too, and aircraft. The majority of aerospace aircraft application use miniature or sub-miniature position transducers, and they are capable acute displacement sensing mechanisms. And coming to the application in satellites, in addition to satellite productions, position transducers are needed for space vehicles, cargo aircrafts, military fighters, drones, experimental aircraft, missiles, nuclear reactors, flight simulators, or high-speed railways. And Lvdt is also using ATM for dollar bill thickness, used for soil moisture testing, in machines for making pills, robotic cleaner. It is used for medical devices for pain proofing. I'm going to the next slide. So before winding up with the presentation, I want to thank faculty in charge Sheetal ma'am, assistant professor in EC department for giving us this faculty. Subject, sensors and applications, subject code 18EIE01. Thank you.
Now let us see how Lvdt practically works using a hardware simulation tool called as a Proteus. In this, we have an input sinusoidal signal source, a potentiometer, a Lvdt transformer, and a bridge rectifier circuit, voltage regulator circuit, Arduino, and a LCD display to display the voltage and the distance or the displacement of the core of Lvdt. Initially, the charge is 0 and the distance is also 0. When the resistance in pot is varied, the voltage is varied and corresponding displacement length is also displayed in the LCD. Similarly, when the pot resistance is varied, the voltage is increased and the displacement